Find somewhere comfortable tonight. Somewhere your body can be heavy and your mind can wander wherever it wants to go. You don't need to follow any of this closely. You don't need to remember a single word. Just let the sounds arrive, the way snow arrives, quietly, without announcement, settling over everything until the world goes soft and still. If today was hard, you can set it down now. Whatever you carried through the hours, the worries, the tasks left undone, the conversations that keep replaying, none of it needs to come with you into this next hour. Tonight we're going somewhere very far away and very deep, somewhere that has been frozen since long before any of us were born, long before the first human drew breath, long before the first fire was lit against the cold. We're going down into the earth itself, into the ground that has not thawed in 700,000 years, into what scientists have come to call permafrost. The frozen memory of the earth. It is a place of immense, unhurried stillness, a place where time moves so slowly it almost seems to have stopped altogether. And on a night like this, when all you really want is to be somewhere quiet, somewhere ancient and undisturbed, that seems like exactly the right place to go. So let your shoulders drop, let your eyes close, or let them rest on whatever is in front of you. It makes no difference. We are in no hurry here. The earth has been waiting millions of years. It can wait a little longer. There is something quietly remarkable about the word itself. Permafrost. It sounds like what it is. Permanent and frozen and vast. The term was coined by an American geologist named Simon William Muller, who was looking for a way to translate a Russian phrase into something the rest of the world could hold on to. The Russians had been living alongside this frozen ground for centuries. They called it Vechnaya Merzlota, which means, more or less, eternal frost. Muller gave it the shorter name, and somehow that name carried with it all the weight and age of the thing it described. The first written accounts of permafrost in the historical record come from 1684, when workers digging a well in the Siberian city of Yakutsk struck ground that refused to yield. They dug, and the frozen earth simply continued downward, meter after meter unyielding. What they encountered that day had been frozen since before their civilization existed. It had been frozen before the city above it was built, before the rivers around it had their current names, before the language in which those workers cursed the stubborn ground had taken its modern form. Even earlier than that, in 1577, the English explorer Sir Martin Frobisher sailed through the Arctic waters searching for the Northwest Passage, that hoped-for route through the ice that sailors had been chasing for generations. He wrote in his journals about encountering ground frozen to depths of 4 or 5 fathoms, even in the warmth of summer. He had no word for it. He had no framework. He simply noted it with the matter-of-fact tone of a man who had grown accustomed to the world, refusing to behave as expected. What those early observers had stumbled upon was something that covers roughly a quarter of all the land in the Northern Hemisphere, an area larger than the combined land masses of the United States, China, and Canada. All of it frozen, all of it ancient, all of it holding within itself a record of the world that nothing else on earth can match. And tonight we are going to drift through it, slowly, gently. The way the cold itself moves, not all at once but gradually, seeping into everything until the whole world is still. To understand what permafrost actually is, it helps to picture the ground beneath your feet, not as solid and simple, but as a kind of layered archive. A library written not in paper and ink, but in soil and ice and stone. At the very top is what scientists call the active layer. This is the part of the ground that participates in the seasons, that thaws in summer, allowing plants to root and animals to burrow, and then refreezes each autumn as the cold returns. In some of the warmer permafrost regions, this active layer can be several meters deep. In the coldest places, it might be only a few centimeters, barely enough to tuck a finger into before the frozen world begins. Below that active layer is the permafrost itself. The boundary between the two is called the permafrost table, and crossing it is like crossing a threshold into another kind of time entirely. Permafrost is not simply frozen dirt. It is a mixture of soil, sand, rock, and organic matter. But with the ice present, it becomes something else. Something that holds its shape across centuries without any effort at all. The thickness of permafrost varies enormously from place to place. In some areas, it extends only a meter or two below the surface. In the coldest parts of Siberia, it reaches down more than 1,500 meters, nearly a mile of frozen ground, stacked layer upon layer, each layer older than the one above it. The deepest layers were frozen before the last great ice ages. Before the woolly mammoth, before the first stone tools, before the slow migration of early humans out of Africa and into the wider world. There is something deeply calming about this if you let yourself feel it. Permafrost is found across Siberia, Alaska, Canada, Greenland, and the high mountain regions of the world, including the Tibetan Plateau, which sits so high above sea level that the cold is not a matter of latitude, but of altitude. In these places, the ground beneath the grasslands and the forests and the tundra has been frozen since before recorded history. The people who live above it have built their lives on something ancient beyond comprehension. And for most of human history, they did so without knowing quite what lay beneath them. The landscape that permafrost creates is distinctive and strange and beautiful in a way that takes a moment to settle into. One of its most recognizable features is what are called ice wedges. Enormous, wedge-shaped bodies of ice that grow within the frozen ground over centuries, pushed deeper and wider each winter as water seeps into cracks and freezes. Over time, these wedges grow large enough to create visible patterns on the surface of the land, great polygonal shapes like the cracked mud of a dried riverbed, but vast and geometric and ancient. Seen from above, a permafrost landscape looks almost like a mosaic or a map of something, some territory without a name. And then there are the thermokarst lakes. When permafrost begins to thaw in places, the ground above it collapses inward as the ice melts, forming depressions that fill with water. These lakes are not calm and picturesque in the way that mountain lakes are. They are the visible sign of something changing underground, the land itself subsiding, rearranging, releasing what it has held for so long. They can appear within a single human lifetime, where before there was only solid tundra. They are one of the ways the earth signals that something deep and old is shifting. And in the forests that grow in permafrost regions, there is another signal, quieter, almost gentle in its strangeness. Scientists call these drunken trees or drunken forests. Standing among them, you might feel as though you had wandered into a place where gravity itself had lost its certainty. The trees are not dead. They are simply leaning into the slow change beneath them, the way all living things must eventually lean into what the earth decides. There is a reason we call permafrost the frozen memory of the earth. It is not merely a poetic phrase. It is, in a very literal sense, what permafrost is. For hundreds of thousands of years, as plants grew and died across the Arctic tundra, as animals moved through the landscape and eventually perished, their organic remains were incorporated into the soil. In warmer climates, this organic matter would decompose relatively quickly, broken down by bacteria and fungi, returned to the air and the earth in a matter of years or decades. But in the frozen north, the cold interrupted that process. The remains of ancient life were captured in the ice before they could fully break down, preserved in a state of suspended incompletion, held there by temperatures that never rose high enough to release them. What has accumulated over those hundreds of thousands of years is staggering. Scientists estimate that permafrost holds somewhere between 1,400 and 1,700 billion tons of organic carbon. To put that in a frame that might mean something, that is more than twice the amount of carbon currently present in the entire atmosphere of the Earth. All of it locked in frozen ground, all of it patient and still. This is the memory the ground keeps. Not in any mystical sense, but in a very physical one. Every ancient summer is recorded there in layers of pollen and plant tissue. Every long winter is preserved in the chemistry of the ice. Every creature that lived and died in those landscapes, from microscopic organisms to enormous megafauna, left something of itself in that frozen archive. And what has been preserved there goes beyond carbon and chemistry. In 2012, a team of Russian scientists made a discovery that seemed almost impossible. Working in Siberian permafrost, they found the tissue of a small flowering plant, Silene stenophila, a delicate thing with narrow leaves and pale petals, preserved in what had once been the winter cache of an Arctic ground squirrel. The burrow had been frozen for 30,000 years. The squirrel was long gone, of course, but the seeds and plant tissue it had stored were still there, still intact, still holding within them the chemistry of life. The scientists carefully extracted the tissue and coaxed it back into growth. And it grew. 30,000 years after it was last alive, the plant produced stems and leaves and eventually flowers. Fertile flowers capable of producing seeds of their own. It was as though the plant had simply been waiting, patient beyond any human understanding of patience, for the ice to release it and the warmth to return. 9 years after that, in the summer of 2021, another team of researchers announced something equally remarkable. From Siberian permafrost, they'd recovered microscopic animals called bedelloid rotifers, tiny, almost impossibly resilient creatures, barely visible to the naked eye. The rotifers they found had been frozen for 24,000 years. When the scientists thawed them, the rotifers woke up. They began to move. And then, in the unhurried way of ancient things returning to their habits, they began to reproduce. 24,000 years of frozen stillness, and then movement. Life continuing from where it had paused. The ground had kept them safe. The cold had held them the way sleep holds us. Not destroying, not dissolving, but simply pausing. Maintaining. Waiting for the right conditions to resume. There is something deeply comforting in that, if you let it settle into you. The idea that the earth itself knows how to hold things carefully through long periods of cold and dark, and release them intact when the time is right. That preservation and patience are not just human virtues, but planetary ones. In the permafrost of Siberia, there are viruses that have not been active since the last great ice age. Not dead. Viruses are not quite alive in the way that plants and animals are alive, and so they cannot quite die in the same way either. They simply persist. Frozen. Waiting. A scientist named Jean-Michel Claverie, working with colleagues from France, Germany, and Russia, has spent years carefully thawing samples of ancient permafrost and examining what awakens within them. In a study published in early 2023, his team announced that they had successfully revived 13 viruses from Siberian permafrost, ranging in age from 27,000 to 48,500 years old. The oldest of these, a Pandora virus, named for the ancient myth of the box that contained everything, was nearly 49,000 years old. It is the oldest infectious virus ever brought back to function. And it worked. When placed in contact with amoebae in the laboratory, it infected them. It replicated. It did exactly what it had been doing. 49,000 years ago, before the ice closed over it and the world moved on without it. These particular viruses infect only amoebae. The permafrost is a vast, largely unexplored archive, and not all of its contents are gentle. Researchers at McMaster University in Canada have found something else in ancient permafrost, something that speaks to a different kind of concern. In samples 30,000 years old, they discovered genes encoding resistance to antibiotics. Antibiotic resistance, it turns out, is not a modern invention. It is ancient. The capacity to resist the chemical weapons that bacteria deploy against each other has been present in microbial life for tens of thousands of years. What the permafrost preserved was a record of that ancient arms race, frozen in place, available for us to read if we look carefully enough. The study of what the permafrost holds is still very much in its early stages. Scientists have sampled a tiny fraction of what is there. The frozen ground of Siberia alone covers an area of extraordinary scale, and most of it has never been studied in any detail. What else is preserved in those layers? What other ancient life, what other chemical signatures of vanished worlds remains largely unknown? There is something quietly wonderful in that uncertainty, in the idea that the earth is still keeping secrets, not hidden out of any intention, but simply held in the cold, the way an old library holds books that no one has opened in decades. Patient, present, waiting for the right reader to arrive. And beneath all of this science, beneath the viruses and the rotifers and the ancient plants, there is something more simply beautiful. The permafrost holds the mammoth. It has held them for thousands of years. Woolly mammoths, preserved so completely in the frozen ground that when they are discovered, they sometimes still have grass in their stomachs, still have the reddish-brown fur intact on their skin, still look, somehow, like animals that simply lay down and went to sleep in the cold. In Siberia and Alaska, these discoveries happen with a frequency that never quite loses its power to astonish. A tusk emerging from a riverbank. A calf, its face still recognizable, its eyelashes still present, lifted out of ground that held it for 20,000 years. The earth held them carefully. For all that time, the permafrost is thawing. Not everywhere and not all at once, but across the Arctic and subarctic regions, temperatures are rising at roughly twice the rate of the global average, and the frozen ground that has been stable for tens of thousands of years is beginning, in places, to soften. This is a slow process, measured in centimeters and decades rather than in sudden events. But it is also, in geological terms, extraordinarily rapid, a change unfolding in years that would normally take centuries or millennia. Researchers at the University of Leeds published findings in early 2026 that illuminated something previously underappreciated about this thawing. As permafrost warms and softens, it becomes dramatically more permeable, up to 100 times more permeable than frozen ground. This means that the gases trapped within it, particularly carbon dioxide and methane, can escape far more easily than scientists had previously modeled. The frozen ground, in effect, was acting as a seal, and as that seal loosens, what was held beneath it begins to rise. The numbers involved are difficult to hold in the mind without a kind of vertigo. If even a fraction of the carbon stored in permafrost were released into the atmosphere, it would significantly accelerate the warming that is already underway. Methane, in particular, is a potent greenhouse gas, many times more powerful than carbon dioxide over short timescales. And methane is one of the things that the thawing ground releases as ancient organic matter, long held in suspended decomposition, finally meets the microbes that can break it down. Professor Paul Glover, who led the Leeds research, noted that approximately 42% of the permafrost in the Arctic circumpolar permafrost region is expected to be lost by 2050. That is less than 30 years away. Within the lifetimes of most of the people listening to these words tonight. And yet, and this is one of the places where science offers something genuinely unexpected, something almost like comfort in its complexity, the story is not entirely one of release and loss. A study published in the journal Nature in June of 2026 by scientists from Umeå University in Sweden and East China Normal University found something that had not been anticipated. In some regions where permafrost is thawing, particularly in areas with discontinuous or patchy frozen ground, the thawing triggers increased weathering of the rocks beneath the surface. Rock weathering is a geological process that has been quietly absorbing carbon dioxide from the atmosphere for billions of years. It is one of the planet's oldest and most patient carbon capture mechanisms, and in these regions the scientists found this geological absorption was significant enough in some places to fully offset, and in some cases exceed, the greenhouse gas emissions from the thawing itself. The Earth, in other words, has its own responses, its own slow adjustments. The processes at work in the frozen ground are not simply a story of loss and release, but of a complex, ancient system responding to change in ways that are still being understood. Science is often presented as a collection of answers, but the most honest scientists will tell you that what they mostly work with is questions, and the permafrost is full of them. The full extent of what lies beneath the seafloor in the Arctic, where permafrost continues underwater, is not well known. The precise timing and magnitude of what will be released, and when, remains a subject of careful, ongoing study. The interactions between the biological processes, the microbes breaking down ancient carbon, and the geological processes, the rocks absorbing new carbon, are still being mapped. What is known is that the Earth is not passive. It is not simply a stage on which human events unfold. It is a system of immense depth and complexity, responding to change in ways that have been developing for billions of years, and the permafrost is one of the places where that depth becomes visible, if you know how to look. Approximately 35 million people live in permafrost zones. They have built cities and roads and pipelines on frozen ground that was, until recently, reliable in its coldness. In some Russian Arctic cities, up to 80% of buildings have suffered damage as the ground beneath them shifts and subsides. The Trans-Siberian Railroad, that great feat of engineering that first drew serious scientific attention to permafrost in the 19th century, was built on frozen ground that its engineers assumed would stay frozen. The assumption held for generations. It is beginning, in places, to require reconsideration. In Alaska, the estimated cost of permafrost-related infrastructure damage between 2015 and 2099 runs to more than $2 billion. Roads buckle. Airports sink. Houses tilt at angles that, in any other context, would look like the work of a playful architect. The drunken trees of the boreal forest are joined, in the human landscape, by drunken buildings, structures that have begun to lean into the slow change beneath them, just as the trees do. There is something quietly instructive in this. The earth changes, and everything built upon it must eventually accommodate that change. The frozen ground that seemed permanent, that was called permanent. Turns out to be permanent only on timescales that dwarf human civilization, on the timescales that humans actually inhabit. It is something more fluid, more responsive, more alive than the word permafrost might suggest. We have traveled a long way tonight, down through the active layer, past the permafrost table, into ground that has been frozen since before the last ice age. We have visited the ancient squirrel burrow where a plant waited 30,000 years to flower again. We have drifted past the tilting trees and the thermokarst lakes and the great polygonal patterns of ice wedges spreading across the tundra like a message written in a language we are only beginning to learn to read. It is a lot to hold, and you don't need to hold any of it. It can drift away, the way all of this will drift away as sleep comes closer. The facts, the numbers, the names of scientists and journals and geological processes. What might stay, if anything stays, is something softer than information, the sense of a world that is older than worry, a ground that has held things carefully through unimaginable spans of time. There is something in that, for a tired mind at the end of a long day. The idea that patience is not a weakness but a form of strength, that things can be preserved through long periods of stillness and cold and emerge eventually intact. That the earth itself practices a kind of rest, not unconsciousness, not absence, but a deep, metabolically quiet holding. A pause between one state and another. The mammoth in the permafrost did not know it was being preserved. The rotifers did not choose their 24,000-year sleep. The ancient plant did not decide to wait. They were simply held by the cold and the dark and the patient earth until the conditions changed. We are not so different in some ways when we finally let the day go and allow the night to do what it is for. The body slows. The breath deepens. The mind, which has been running since morning, begins to lose its grip on the details it has been clutching. The unfinished things, the uncertain things, the things that felt urgent in the daylight and feel, now, simply distant. The frozen ground of Siberia is covered tonight by stars that have been there since long before the permafrost formed. The same stars, more or less, that shone on the squirrel as it tucked its seeds into the earth and then curled into its own long winter sleep. The same cold, patient dark that has presided over 10,000 generations of creatures finding their way through the night. You are part of that continuity. Small and warm and present in this particular moment, but connected somehow to all of that deep time, to the ancient ground and the ancient sky and the ancient silence that underlies everything. Somewhere below the surface of things, below the noise of the day and the concerns of the week and the worries that feel so immediate and so large, there is something frozen and still and very old, something that does not respond to urgency, something that simply holds. You can rest there if you like. Not forever, just for tonight. Just for the next few hours, while the world outside goes quiet and the dark does its slow, patient work. The scientists who study permafrost speak sometimes of its role as a record keeper. A keeper of past climate conditions, past ecosystems, past versions of the world. Every layer of frozen ground is a page in a book that stretches back further than we can easily imagine. And reading those pages carefully and slowly, we begin to understand something about the long arc of things. About how the world moves not in straight lines but in cycles. Warming and cooling, freezing and thawing, holding and releasing. We are always somewhere in that cycle. Always between one state and another. And the night is one of those thresholds, the place where the day releases its grip and the body begins its own quiet restoration. Its own version of the permafrost's patient preservation, the slow repair of cells, the consolidation of memory, the gradual return of the resources that tomorrow will require. Sleep is not nothing. It is not simply the absence of waking. It is a process as ancient and necessary as anything the earth does in its long cycles of cold and warmth. Your body knows this, even when your mind forgets. The heaviness you feel right now is not failure. It is the body remembering what it is for. Let the weight of it settle. Let the thoughts thin out the way clouds thin at the edges before they dissolve entirely. There is no particular destination tonight, no conclusion to arrive at, only the gradual deepening of the quiet, the slow fading of the day's residue, the soft arrival of something that has been waiting patiently at the edges of your awareness since the evening began. The permafrost holds its carbon and its ancient life in the dark beneath the tundra. The stars above Siberia tonight are cold and very far away. The drunken forests lean gently in whatever wind is moving there, and the thermokarst lakes reflect the sky, and somewhere deep underground, in ground that has been frozen since before the first human language was spoken, there is a stillness that has nothing to prove and nowhere to be. That stillness is very old. It has been there through everything. Through the ice ages and the warm periods and the slow drift of continents and the rise and fall of every species that has ever lived on this planet. It was there before us, and it will be there after us, and tonight, for a little while, you can borrow some of it. The active layer of the earth thaws each summer and freezes each winter, and has done so for as long as the permafrost has existed. And every night, something like that happens in a human body. The surface activity quieting, the deeper processes taking over, the metabolism dropping towards something slower and more ancient. The two things are not the same, but they rhyme in a way. They share the same unhurried patience. Whatever you are carrying tonight, whatever the day left in your hands that you haven't quite been able to put down, the frozen ground has been holding things far heavier than that for far longer than you can imagine. It is good at this. The earth is very, very good at holding things safely through the dark. And so we leave it there. The permafrost beneath the tundra, the ancient viruses in their long sleep, the tilting trees and the polygon landscapes, and the 30,000-year-old flower that opened when the ice finally let it go. Somewhere behind you, the day is already distant. Let it stay there. The ground is patient. The dark is old. You are held. Sleep well. There is a particular kind of ice found within permafrost that deserves a moment of quiet attention. Scientists call it massive ice. Not because of any dramatic quality, but simply because of its sheer scale. In some locations across the Yukon and the Northwest Territories of Canada, sheets of massive ice lie buried beneath thin layers of soil, stretching horizontally for hundreds of meters, in places several meters thick. These are not the remnants of glaciers. They are ice that formed in place, slowly, over centuries, as water infiltrated the frozen ground and was captured there before it could drain away. When you stand on the surface above a sheet of massive ice, The ground looks ordinary. A little boggy, perhaps, in the summer months. Perhaps a few low shrubs, a scattering of sedge grass. Nothing to suggest that a few meters below your feet there is something that has been frozen since the last ice age. Something that, if melted, would cause the ground you are standing on to collapse entirely. The Inuit and Yupik peoples of the Arctic have lived alongside these landscapes for thousands of years, and their languages hold within them a knowledge of the frozen ground that Western science only began to develop in the 20th century. The Yupik word for the kind of ground collapse that happens when buried ice melts is one that carries in it a whole understanding of the landscape's behavior, not as an anomaly or a disaster, but as something the land does, something to be known and respected and built around. This knowledge, accumulated across generations of careful observation, is increasingly being sought out by researchers who recognize that the people who have lived on permafrost the longest understand things about it that instruments alone cannot easily measure. One of the most striking examples of this collaborative knowledge gathering involves the monitoring of a particular stretch of coastline in northern Alaska, near the village of Utqiagvik, the northernmost city in the United States. Local hunters and fishermen had been observing for decades that the coastal bluffs were retreating, that the sea was claiming land that had been solid within living memory. When scientists arrived with their instruments and their satellite imagery, they found that the rate of erosion was accelerating, driven in part by the thawing of ice-rich permafrost in the bluffs themselves. The ice melts, the soil loses its structure, and the sea takes what the cold had been holding together. In some places along the Alaskan coast, erosion rates of 10 to 15 meters per year have been recorded. Entire stretches of land that appear on maps from the mid-20th century have simply ceased to exist. There is a village on the Alaskan coast called Shishmaref, home to a community that has lived on its barrier island for centuries. The permafrost beneath the island has been thinning. The sea ice that once protected the coastline from winter storms has been arriving later and leaving earlier, and the combination has put the island itself at risk. The community has been debating relocation for years, a conversation that involves not just logistics and cost, but the deep, complicated grief of leaving a place that has been home for generations. The land they would leave behind would not simply be empty. It would carry within it the frozen remains of everything their ancestors built there, everything they planted and buried and left behind, slowly releasing into the warming sea. These are not abstract stories. They are the human dimension of the slow change in the frozen ground, the part of the permafrost story that does not appear in scientific papers, but that is felt in the bodies and the choices of real people navigating a landscape that is shifting beneath them. The oldest permafrost yet dated lies beneath the Tibetan Plateau, at an altitude where the cold is maintained not by Arctic latitude, but by the sheer height of the land above the warming influence of the lower atmosphere. Cores drilled from this ancient ground have yielded material frozen for more than 800,000 years. 800,000 years of climate history compressed into layers of frozen soil, each layer a chapter in a story that began long before our species existed. Reading those layers is painstaking work. Scientists use a range of techniques, analyzing the chemical signatures of ancient pollen to reconstruct what plants were growing when each layer was deposited, examining the isotopic composition of ice to infer past temperatures, studying the remnants of ancient soil organisms to understand what ecosystems once flourished there. It is slow, careful, deeply patient science. The kind of science that suits its subject. Among the most extraordinary findings from these deep cores is the evidence of what scientists call abrupt climate transitions, moments in Earth's past when the climate shifted relatively quickly from one stable state to another. These transitions are visible in the permafrost record as sharp changes in chemistry and biology between adjacent layers, layers that might represent only a few centuries of time within a core that spans hundreds of thousands of years. They are a reminder that the climate system, while capable of extraordinary stability over long periods, also has thresholds. Points at which the accumulated pressure of gradual change tips suddenly into something different. The scientists who study these transitions are careful not to draw simple parallels with the present. The Earth's climate system is complex beyond any easy analogy. But what the permafrost record offers, and what no other archive quite matches, is the depth of context it provides. When you can read 800,000 years of climate history in a single core of frozen ground, you begin to develop a sense of the range of conditions the planet has experienced. The warmth and the cold, the wet and the dry, the periods of stability and the moments of transition. And within that vast context, the present moment becomes both more intelligible and more clearly significant. There is a researcher at the Alfred Wegener Institute in Germany named Guido Gross, who has spent much of his career studying the lakes that form as permafrost thaws, the thermokarst lakes we drifted past earlier in our journey tonight. His work involves not just measuring the lakes that exist now, but reconstructing, from sediment cores and satellite imagery and historical records, the history of how these lakes have formed and disappeared across the Arctic over the past several thousand years. What he and his colleagues have found is that thermokarst lakes are not simply a product of modern warming. They have formed and drained and reformed across the Arctic many times in response to past climate fluctuations, leaving behind them a record of each cycle in the sediments at their edges. Some of the lakes that dot the Siberian tundra today are ancient, formed during the warm period that followed the last glacial maximum, when temperatures briefly rose above modern levels before cooling again. Others are new, forming within the past few decades in places where the permafrost had been stable for thousands of years. Reading the difference between these old lakes and new ones, between the sediment records of past thaw cycles and the current one, is part of how scientists are trying to understand what is happening now in the context of what has happened before. The ground keeps its records carefully. It does not editorialize. It does not catastrophize or minimize. It simply holds what happened, in the order in which it happened, layer by patient layer, waiting for someone to come along and read it. In the summer of 2020, in the permafrost of the Sakha Republic in northeastern Siberia, a cave lion cub was discovered in a state of preservation so complete that the researchers who found it initially struggled to accept what they were seeing. The cub, which was eventually named Sparta by the scientists who studied it, was approximately 28,000 years old. Its fur was intact. Its whiskers were present. The soft tissue of its nose and paws had survived the millennia in the frozen ground. Sparta was so well preserved that researchers were able to determine not just its age and species, but details of its anatomy that had never before been available for study. The precise structure of its paw pads, the texture of its coat, the size and placement of features that in any other fossil would have been lost to time. Alongside Sparta, in the same region, another cub had been found 2 years earlier. Boris, approximately 28,000 years old as well, similarly preserved, similarly complete. The two cubs were not related, as far as the scientists could determine. They simply shared a landscape and a fate. The frozen ground claimed them both in different moments of their short lives and held them until the modern world arrived to find them. The cave lion, Panthera spelaea, was one of the great predators of the Pleistocene. Larger than most modern lions, it ranged across Europe and northern Asia during the last ice age, sharing its territory with mammoths and woolly rhinoceroses and the early humans who painted its image on cave walls in France and Spain. The cave paintings at Chauvet, some of the oldest known, include detailed depictions of cave lions, animals rendered with a care and accuracy that suggest the artists who painted them were deeply familiar with their subjects. And now, 30,000 years after those artists laid down their pigments, the animals themselves can be studied in 3 dimensions, their actual forms preserved in the same frozen ground that preserved the pollen and the seeds and the ancient viruses. The permafrost holds all of these things together. The art and the animal, the microscopic and the magnificent, in the same patient, undiscriminating cold. There is a scientist named Hendrik Poinar, a geneticist at McMaster University, who has spent decades extracting and analyzing ancient DNA from permafrost specimens. The quality of genetic material recovered from frozen specimens far exceeds what can be obtained from fossils preserved in other ways. The cold slows the chemical degradation that destroys DNA over time, in the same way that it slows all other biological processes. From mammoth remains recovered in Siberian permafrost, Poinar and his colleagues have been able to reconstruct substantial portions of the mammoth genome, comparing it to the genome of the modern African elephant, the mammoth's closest living relative, and identifying the specific genetic differences that gave the mammoth its distinctive adaptations to the cold, the extra layer of subcutaneous fat, the hemoglobin that delivered oxygen efficiently at low temperatures. All of it written in the DNA, preserved in the ice, available to be read by researchers working in modern laboratories using techniques that would have been unimaginable to the scientists who first identified permafrost as a scientific subject of study. Some researchers have gone further, exploring whether the genetic information preserved in permafrost specimens might one day contribute to efforts to restore something like the mammoth to the Arctic tundra. This is science that moves carefully, and the conversations around it are complex and ongoing, touching on questions of ecology and ethics and the limits of what is possible. But the frozen ground has already provided the raw material. The genetic blueprint of an animal that last walked the earth 4,000 years ago, preserved in a state of extraordinary completeness, waiting. The last wild mammoths did not live in Siberia. They lived on Wrangel Island, a remote Arctic island north of the Siberian coast, where a small population survived in isolation for thousands of years after their mainland counterparts disappeared. The Wrangel Island mammoths were still alive when the pyramids of Egypt were being built. They were still alive when the first cities of Mesopotamia were rising from the plains between the Tigris and the Euphrates. They were still alive on their cold and distant island as the ancient world was taking the shape we recognize from history. And when they finally disappeared, the permafrost of the Arctic was already ancient, already holding its long archive, already patient in the way that only truly old things can be patient. There is a quality to deep cold that is difficult to describe to someone who has not experienced it. Not the cold of a winter morning or an open freezer, but the cold of a place where the temperature has not risen above freezing in centuries. It is a stillness that goes beyond physical temperature. It is as though the air itself has stopped hurrying, as though time has agreed to slow down just in this place, just for a while. People who work in the Arctic often speak of this quality. Researchers who spend months at remote field stations on the Siberian tundra describe a gradual settling that happens within them. Not immediately, but over days and weeks of living in the quiet of the frozen landscape, the absence of the usual rhythms of civilization, the traffic, the notifications, the constant small urgencies of connected life, creates a kind of spaciousness that most of them had not expected. Some find it uncomfortable at first, and then, slowly, they find it something else entirely. A glaciologist named Katarzyna Marcis, who has worked extensively in Arctic peat bogs, those saturated, partially frozen landscapes that are cousins of the permafrost in their capacity for preservation, described in an interview the experience of standing alone on the tundra at the end of a long fieldwork day in the particular quality of Arctic summer light that never quite darkens. She said that what struck her more than anything was the sense of being held by the landscape, not watched, not judged, not evaluated, simply held. The way, she said, that a very old place holds everything that has ever existed within it, without preference, without urgency, without any expectation of what you might do next. That quality of being held without expectation is one of the things the night offers too, if you let it. The dark outside your window is not waiting for you to perform or produce or resolve anything. It is simply there, patient and vast, the same dark that has covered every sleeping creature since the first night fell on the first life that needed rest. In the language of the Saka people of northeastern Siberia, there are words for the frozen ground and the frozen air and the frozen river that have no direct equivalents in other languages. Words that carry within them a relationship to the cold that is not adversarial, not something to be overcome, but something to be understood and accommodated, and, in a certain sense, respected. The Saka have lived in one of the coldest inhabited regions on Earth for thousands of years. Yakutsk, the city built above that well that refused to yield in 1684, regularly records winter temperatures below -50 degrees Celsius. It is one of the coldest cities on the planet, and it is a city that has been continuously inhabited for centuries by people who found in the extreme cold not an obstacle to life, but a condition of life, something to be known intimately and navigated with care. There is a word in Russian, tauska, that carries within it a kind of longing that has no precise English equivalent. A yearning for something unnamed, something perhaps not fully known. Writers have sometimes used it to describe the feeling that the vast empty landscapes of Siberia can produce in those who travel through them. The sense of being very small in the presence of something very large and very old, and of that smallness being, somehow, not diminishing but clarifying. The permafrost is part of what produces that feeling, the knowledge, even if only dimly sensed, that the ground beneath you has been frozen since before your civilization existed, that it holds within it the remains of creatures you have only seen in paintings and museum reconstructions, that it is keeping its own slow record of everything that has passed across its surface. That knowledge, held lightly, produces something that is not quite awe and not quite peace, but something that is not quite awe and not quite peace, but something in between, something that makes the ordinary urgencies of daily life feel, briefly, like what they are, small events on the surface of a very large and patient world. You are, tonight, a small and warm event on the surface of that world. Your worries are real. Your tiredness is real. The things that pressed on you today were real, and they are also, in the context of the ancient frozen ground and the 30,000-year-old flowers and the stars above the Siberian tundra, very, very small. Just small. Just held within something vastly larger than themselves, the way everything is, always, whether we remember it or not. The permafrost does not know your name. It does not know anyone's name. It simply holds what it has always held, in the dark, in the cold, in the patient and unhurried way of things that have been here far longer than memory. And tonight, that is enough. More than enough. It is, in fact, exactly what a tired mind needs to hear before sleep arrives. That the world is older than your worries and deeper than your fears, and that somewhere beneath the surface of everything there is a stillness that nothing disturbs.